So number 1 was the one with the table and the Riemann sums. So it's t and a of t. And it's 0, 5, 2, 4, 8, 6, and 3. And so it says that we want to know the velocity of this. And it says we want to know the velocity of this at time 6. So we want to know what is v of 6. And then the other information it gave us was that it basically told us that v of 0 is equal to 11. So remember what I said is when we do this integral, if we do the integral from 0 to 6 of acceleration, what the integral is going to tell us is it's going to tell us the change. So if you want to set it up the way, like the fundamental theorem of calculus, it's technically just v of 6 minus v of 0. This is the same thing. If you want to just think of it as a change, you could think of it as a change. Okay, I don't know what v of 6 is. I do know v of 0 is 11. And it said to do this using a left-hand Riemann sum. So to do a left-hand Riemann sum, it's going to be b minus a. b is 6 minus 0 divided by n. 1, 2, 3 intervals. And I told you 3. And then left hand. So left hand I do 5 plus 2 plus 8. We skipped the last one. Right hand I would have skipped the first one. So 5 plus 2 plus 8. That's 10, 15. 6 divided by 3 is 2. So 2 times 15 is 30. Okay, again, this means that's the change. What did I start off at? 11, so you could just know 30 plus 11 is 41, or you could set it up as 30 equals v of 6 minus 11, add over the 11, either way you get 41. Number 2 should have been a little bit easier and straightforward. Number 2 was the integral from 0 to x of e to the negative t squared. And it wanted us to find the derivative at x. If I'm going to take the derivative of this, okay, personally I would just write in d dx. And when we're doing the derivative, it goes there and there. And so we get e to the negative x squared. Do I need to put plus c? Yeah, why not? Yeah, it's a definite integral. This 0 will cancel out because we're doing a derivative of it, and the derivative of a constant number is just 0. All right, number 3 in this case was the question we have the integral from 1 to 4 of f of x dx equals 5. The integral from 1 to 6 of f of x dx equals 3, negative 3. And we wanted to know what is the integral from 4 to 6 of f of x dx. So these problems, we always want to set up, basically if I want this bottom one is what's going to be canceled out. This bottom one is what starts on the bottom. The top one's going to end on the top, and the middle one's going to have to cancel out. So I know that 4 has to be on the bottom. Right now it's on the top. So I have to flip it. So that means I'm going to basically change this to integral from 4 to 1 of f of x dx equals negative 5. Right, because I flipped it. Now I have 1 on the bottom, 6 on the top. 6 is supposed to be on the top. So now I can basically say, if I go from 4 to 1 plus from 1 to 6, that's going to get me to from 4 to 6. So from 4 to 1 was -5, plus from 1 to 6 was -3. -5 plus -3 is next one. This next one was just a little bit tricky, and that was the question that said which is equivalent to ln of 4. So basically, which one of these has an answer of ln of 4? And it gave you ln of 3 plus ln of 1. This was an AP test question. Actually, most of these I got from old AP tests, and I just changed the numbers around. This one I think I actually left the exact same. So integral from 1 to 4 of e to the t dt. Then we had integral from 1 to 4 of ln of x. And integral from 1 to 4 of 1 over t dt. This is a question where if I saw this on an AP test, I might attack it like one of two ways. I might just quickly look and see if anything pops out to me. And if it doesn't, I might go through each one. Okay, so if letter E pops out to you and you just realize like the integral of 1 over t is ln, that's ln of 4 minus ln of 1, and you remember ln of 1 is 0, and you just circle E, great. If not, I'm going to go through them step by step. So ln of 3 plus ln of 1, you can't add them, they're not like terms. Okay, you don't get to add these. In fact, if anyone remembers, there's like adding and multiplying rules that work, but you can't add them up. They're not like terms. Okay, ln of 1 means to do the natural log of 3, it's going to give some answer, and then the natural log of 1. Okay, and if you remember, ln of 1 is actually 0, so this is not. Okay, ln of 8 divided by ln of 2. If anyone remembers, when you divide logs, what do? Subtract, so this would have actually been the ln of 6. Okay, what's the integral of e to the t? So this is e to the t from 1 to 4, which is e to the 4th minus e to the 1, not ln of 4. Okay, and then the integral of ln of x we haven't talked about, but the integral of ln of x, it's not ln of x anymore. So if you were just kind of thinking about this, it would be something different than ln of x. I'm not going to cancel it out now if we don't know for sure, but I'm just going to kind of say we don't think it's this one. And then what's the integral of 1 over t? ln. So this is ln of t from 1 to 4, which is the ln of 4 minus the ln of 1. And we said earlier the ln of 1 is 0, so it's just ln of 4. Alright, any questions so far? Alright, next question we have is the integral from -2 to 2 of x to the 7 plus k dx equals 16. I'm going to go over this one a little bit more quickly since we didn't class yesterday. But if I wanted to solve for this and get k, okay, we can say u equals x to the 7th plus k. So, is that what we did? Yeah. Oh yeah, we just did the integral. There's no u substitution here because it's not a u. Yeah, it doesn't need it. It's a plus. Remember when we have a plus, it's just a separator. Alright, so what's the integral of x to the 7th? So it's x to the 8th over 8 plus what's the integral of k? It's a constant, so just k x from -2 to 2. which we plug in 2. We get basically, I'm not even going to worry about what it is. We get 2 to the 8 divided by 8 plus 2k, right, because we're plugging it in for x. And then minus, okay, negative 2 to the 8th power is going to turn positive. So even though we have negative 2 to the 8th, since it's to a positive power, you can just know that this is going to turn to a positive number. Divided by 8, and then it's plus negative 2. So you'll see that these two are going to cancel. Even if you don't know what the number is, they're going to cancel because it's the same thing. And then 2k minus negative 2k becomes 4k equals 16, right? Because this integral is equal to 16. Divide by 4, we get k equals
4.
So it's a particle moves along the x-axis with a velocity of 3t squared plus 6t. And it says if the particle is at position x equals 2 at t equals 0, okay, you can rewrite that. If you want to rewrite that, we can rewrite this as x of 0 equals 2. We're plugging in 0 for t, we're plugging in 2 for x. You don't have to rewrite it, but you can. And it says, what is the position at time equals 1? And when we're saying what is the position, that's asking for the x value. Okay, well, we have a formula for v. How are we going to get it to x? We take the integral. Right? If I wanted to get to acceleration, I do derivative. And to get to position, I do the integral. So I do the integral of both sides. When I do the integral of v, it gets me to x. And then the integral of 3t squared becomes 3t cubed over 3, or just t cubed. Plus the integral of 6t is like 6t squared over 2. Right? Which would become
3t squared.
6 divided by 2 is 3t
Squared.
squared. And then we also need, since there's no endpoints, we need a plus c. And this right here is my initial condition. That's going to help me solve for the c. So I plug in, basically for the x, I plug in 2. And then I plug in for time, I plug in 0. So 0 cubed plus 3 times 0 squared plus c. Right? So that gives me 2 is equal to c. So now I can go back to my equation and just change this to a 2. So I have t cubed plus 3t squared plus 2. That's what x is. If it asked you to find a formula for like the position, that would be your answer. But it asks, what is the position at time 1? So I just plug in 1. So I'm going to have x of 1 equals 1 cubed plus 3 times 1 squared plus 2. 1 plus 3 plus 5, 6. I know I did mention this during the Riemann notes. So, number 7 gave us a graph. And it basically said which one of these has the least value. So which one of these least value would mean it's the smallest. So A was just the straight integral. This was from 0 to 3. So A was just the straight integral from, 1 is right about here, from 1 to 3 of f of x dx. Okay, what would be this on the graph? What would it look like? Basically from 1 to 3, it would just be that whole section's over. Okay, that's what the integral is. Okay, B says a left Riemann sum. So B is a left-hand Riemann sum from 1 to 3 with 4 intervals. So n equals 4. That means I have to split this up into 4 sections. So like 1, 2, 3, 4. And I go from the left side, so I'm going to go from the left. Okay, is this bigger or smaller? That section. Like if I shaded all of this in, bigger, right? Because it's going to have these extra little pieces up here. So this is bigger. I want the least value. Can't I already cross this out?
Yeah.
Okay, C is a right Riemann sum. So C is a right hand Riemann sum, same concept, but now I'm going from the right side. So I'm going to go here. This actually is 0. Okay, that whole rectangle will just be 0. Then I go from here. And I go from up here. Okay, you don't really have to draw this to be like, I'm drawing it all the way out. If you're doing this on a test, personally, I would just know that you see this graph and you think, okay, the regular interval is everything. From the left, I just draw one big one. It's going to be above it, and from the right, it's going to be below it. So right now, I'm thinking this is the smallest, so I can cross out A. Okay, then D and E are both very similar. D is midpoint, and E is trapezoid. Both of these are going to be, midpoint is starting in the middle. Okay, midpoint and trapezoid are usually pretty accurate. So E is in the middle. Do we see how that's already going to be bigger than the right hand? And then E is trapezoid, which is very similar. You go, kind of make that line and turn it into a trapezoid, which again, it's going to be very, very similar to midpoint. They're both really accurate. They're closer to this. So you can see it's bigger than the one that really under approximated a lot is the right. So it was a bonus. You didn't get it, it's okay, but I do want you kind of thinking about it. All right. 8 was, so the answer was C. It's the right one. Because it's, if you think about it, if you think about it as one big graph, okay, and you don't even have to worry about breaking it into intervals. But if you just think from 1 to 3, the integral is going to be the exact area. So this is like the exact section underneath it. If we think about left hand, like one big left hand would look like that. Is that an over or under?
Over.
So this is over. So A was exact, B is over. Okay, C, if we think about one big rectangle, it's going to be from down here. That's under. And then D and E, midpoint and trapezoid, on this kind of a question, it's never going to be the answer. But midpoint and trapezoid, midpoint would be here. Can we really tell if that's over or under very well? No, it looks like maybe that's a little bigger, but it's pretty close. Right? This one's definitely over, this one's definitely under, this one's kind of close. And then trapezoid is, I go from here to here and make a section. This is going to be under, right? But at the same time, it's less under than that was. Right? That was like way under, so that answer is. All right, number 8 was the question where it said the integral from -5 to 2 of f of x is equal to -17. This is another one of just, do you know your properties, like those adding up, flipping it to make it negative. So the integral from -5 to 2 of f of x dx equals -17. The integral from 5 to 2 of f of x dx equals -4. And they want to know what is the integral from -5 to 5 of f of x dx. This is very similar to the other question, like this, where I want this to be on the bottom. Is it on the bottom? Yeah. I want this one to be on top. Is it on top? Right? It's right here, so we got to flip that one. So we're going to flip this one, which makes it the integral from 2 to 5 f of x dx equals +4. Right, we flip it. So now we can basically say I'm starting at 2. Starting at -5, going to 2. That gave me -17, and then I continue on at 2 and go to 5, and I went up. Okay, so integral from -5 to 2 plus integral from 2 to 5 equals integral from -5 to 5. And that's how I usually set these up when I'm trying to solve them, is just get this number on the bottom, right? And get this number on the top, and then these two should be the same, they cancel out. So it's -17 plus 4, which is -13. Number 9 was a little bit tricky to think about, but if you know your rules for integrals, fundamental theorem of calculus, it's not too bad. It says g of x is an antiderivative. What does that mean? It just means it's the integral of f of x. And then it says that g of 2 equals -7, and it wants to know what is g of 4. Okay, one thing to just make sure we know about this is if g of x is an antiderivative of f of x, and I see 2 and 4, I know those are x values, right? Before you even look at the question, I'm kind of expecting something in the likes of from 2 to 4 of f of x is equal to, what did we say? First fundamental theorem of calculus is basically like big F of 4 minus big F of 2. We need to know this. This is like the fundamental theorem of calculus. We absolutely need to know it. Okay? But instead of F, they're just calling it G. And now all of a sudden, okay, I know that, I don't know the answer here, but I do know that this one is -7. Right? So I can replace this with -7, and then the negative and the negative make it positive. And I want to solve for g of 4. Couldn't I just subtract 7? So I get the integral from 2 to 4 of f of x dx minus 7 equals g of 4. Now, I know that I just did this without even looking at any of the questions, like the answer choices. On an AP test, I wouldn't recommend doing that. I'd like actually look at the choices. But it's just something to think about, to have in your head, that first fundamental theorem of calculus. So when it says a f prime of 4, okay, would the integral be the same as the derivative? Is the integral the same thing as the derivative? No. Okay, then when it says b is -7 plus f prime of 4, again, same thing. This is an antiderivative. It has nothing to do with the derivative. Okay, c is the integral from 2 to 4 of f of t dt. Again, this is closer, but what this is equal to is it's equal to g of 4 minus g of 2. So this isn't correct unless it had said g of 2 was 0. Then would it have been correct, like if you subtract 0? So that one's not right because it's still minus g of 2. And then d D is kind of deceiving. Why is D wrong? Negative 7 plus f of t dt. Why is D wrong? So how is this different than what I wrote? Right here, I'm just doing the integral of f of x dx, and then that answer I'm subtracting 7. This is saying I'm doing the integral of negative 7. It's not negative 7 anymore, it's, if I did the integral of negative 7, isn't it negative 7x? From, in this case, 2 to 4, which is going to be like negative 28 minus negative 14. So it's a different answer. So that's why this one's wrong. Which leaves E has to be the right answer. And it's negative 7 plus the integral from 2 to 4 of f of t dt. Okay, these kinds of questions, when I was taking AP Calc, these were the questions I always got wrong. They're actually really, really, really easy. But what you have to just think in your head is, this would be my strategy kind of, is anytime I see the word antiderivative, okay, anytime at all I see antiderivative, I'm going to write down like integral f of x dx. And then I see two x points, these are x's, right, x and x, like g of x, so I'm going to put those in here. And your first thought should be to do the integral. But can I do the integral of this? Yeah. Do I know what the integral is? Like, is it one where I could just do like 3x plus 4? In this case, can't I say like 3x is 3x squared over 2? Can I do that here? No. So when you can't do that, that's when you go to that first fundamental theorem of calculus and just think f of 4 minus f of 2. And when you do that, it kind of helps you to see that it's going to be. So now that I don't know how to math, I'll do the last one. Alright, the last multiple choice said to use the table to get the integral from 1 to 3 of f prime of x dx. And then it gave us this table. And before I fill out the table, okay, what I want to think about is if I'm doing this integral. Okay, this is another one where it's not, integral of 6t squared. It's the integral of an f. Okay, f prime. If I'm doing the integral of f prime, okay, what is the integral of f prime? F. And the fundamental theorem of calculus tells us when we have these endpoints, it's going to be equal to f of 3 minus f of 1. Did we even need this bottom row? No. Okay, so we just go to where it's 1, and at 1 it was at 4, and we go to where it was 3, and at 3 it's 2. So that means f of 3 is equal to 2 minus f of 1 is equal to 4. 2 minus 4 is negative 2. Of 6t squared plus 1 dt. Okay, integral of 6t squared is 2t cubed plus t from 1 to 2. Plug in 2. 2 cubed is 8. 8 times 2 is, so it's 16 plus 2 minus 1 cubed is 1 times 2 is 2 plus 1. That gives us 18 minus 3 is 15. You know it changed by 15? What was your final answer? It got to 32. If it went up by 15 to get back to the original, you just do. Okay. Alright, so that is the final answer. I'm sorry. Sorry. Number 12 was the integral from 1 to 2 of 3x minus 2 cubed dx. Okay, as soon as you see something like this where it's something other than x being cubed, you can know it's u substitution. So our u is usually the inside or the kind of more complicated term. So u is 3x minus 2, du is 3 dx. That makes this the integral. We're going to change our endpoints, plug in 1. 3 times 1 is 3, minus 2 is still 1. So even though I changed my endpoint, that one didn't change. 2, when I plug in 2, 3 times 2 is 6. Minus 2 is 4. So the top one did change. Okay, of u cubed du. What's the integral of u cubed? U to the fourth over 4. Why do I not have to put plus c?
Because it's a definite integral.
Definite, good. Okay, 4 to the fourth. Okay, even if you don't know what 4 to the fourth is, I gave you the crappy calculators. Yeah.
What? If it's like d3 dx.
Oh, yeah, thank you. Yeah, I need to add in a 3, right? That's my fault. This is the u. This is the u. I need to add in the du. So if I put 3 here, what do I put outside?
1/3.
Alright, this becomes 1/3 times, okay, even if you don't want to put it, just how about 4 to the fourth divided by 4 minus 1 to the fourth divided by 4. Even if you don't know what 4 to the fourth is, couldn't you cancel out 1/4? So if you didn't know what 4 to the fourth was, and you didn't figure out that you had a calculator, you could do this. What's 4 cubed? That's one we should know. 64. So this is 1 over 3 times 64 minus 4. Honestly, on the AP test, if it's a short answer, you can leave it like that. Full credit. If you left it like that on this test, full credit. Okay, if you really want to do some math, 64 minus 1/4. Okay, you could. And you could get basically 63 and 3/4, and then you can multiply and keep going. That's a lot. Okay. The answer actually ended up being 85 over 4. One thing that you could do that might work is instead of, see how like when I cancel out the 4, it gets rid of my common denominator? So maybe a different strategy is just doing 4 to the fourth power is 256 over 4 minus 1 over 4, which gives you 1/3 times 255 over 4, which is 255 over 12, because you just multiply across. And 255 over 12, you can divide both of these by 3, and you get 85 over 12. Okay, so next question was that one with sine cubed. A lot of people got this wrong, and I was a little sad because it's actually probably one of the easiest questions on the short answer. So if you pay attention to this one, these questions are actually a lot easier than they seem. Okay, it's kind of like in chain rule. Do you remember how in chain rule we kind of took that cube and we just moved it so it looked like this? And that's going to help you like see it a little bit better. So if you move it here, do you see that this is kind of like your inside and this is your other one? So that means on u substitution, u is going to be sine of theta. What's the derivative of sine of theta? So I have my cosine of theta, so that's going to become du. So this is just the integral of u cubed du. I don't change endpoints. Why not? Because there aren't endpoints. So in this kind of u substitution, you just do the integral. It's u to the fourth divided by 4 plus c. Right? Don't forget the plus c. I didn't want the answer with u's, though I wanted it with theta. So I plug back in. Sine of theta to the fourth, you can write as sine to the fourth theta over 4 plus c. If you put the fourth outside, you can do that. Just make sure to do a parentheses or a bracket. Otherwise, they'd think it was with the theta. Okay. But that one, I know we can all do. Okay, we just got to really remember to experiment, to try like, which one is our u, which one's our du. The more you practice those, the better you guys are going to get at. Okay, I know that I haven't talked about this in a while, but honestly, if you like type this, if you don't know how to do it and you type it into Symbolab, and you just press show steps, just seeing them over and over, it really does help. So even if you never did that like extra credit integrals, like all of them, if you want to go back and just start typing some of them into Symbolab and just looking at them and kind of thinking about it, it really does help. Yeah, Brenda, question? How did I what? Okay, yeah, how did I figure out u? Good question. So when you have this, you want to think like that u is generally your inside term. Sometimes you just have to experiment with it and like mess around. But let's say I thought it was going to be theta. If I make u theta, what's du? Just 1 d theta, and I get the integral of sine cubed of u cosine of u du. Does that really help us out? No. So once I know it's not like a theta, and generally speaking, this is just like a general rule, if it's just theta, your u is not going to be theta. If this had been like a 3 theta, then maybe. But, for the most part, if it's just sine and cosine, like if you see both of them, it's usually your u is either going to be sine or it's going to be cosine. And how did I know it's sine and not cosine? Because this one is being cubed. So the one that's more complicated is like 99% of the time your u. So since sine was being cubed, I knew that it was going to be my u. You can't really know that until you do a lot of these problems and you start to see the patterns. And you can just guess. Could I have guessed u as cosine? Yeah. And then that makes du negative sine. In that case, wouldn't I have to add a negative? So I have like negative integral. But then see how it's cubed? Well, I don't have it cubed, I just have it to the first power. So does it work? No. So then you can try sine. But once you see a bunch of them, you just know, okay, that one's a little more complicated, so it's going to be my u. And it's not theta, it's the whole sine theta. That's why I was saying if you kind of rewrite this as the whole thing cubed, you can see that that's what you want to make your u. Everything inside is u. But good question. The more you do of these, the better we're going to get. It's just kind of practice knowing what your u is going to be. There's no really quick short answer of like how to perfectly know what your u is. You just got to keep doing it. So 14.
Figure 4.
Integral of e to the negative x dx. So again, this is one where if it was e to the x, you know the integral is just e to the x. Since it's e to anything else, we need to do a u substitution. And again, you could make your u like e to the negative x, but then your du is negative e to the negative x. And do I have another term in there like that? No. So in this case, my u is just going to be the exponent to negative x, which makes my du negative 1 dx. I'm missing the negative, so I put the negative inside and I put it outside. This becomes my du, and then this becomes my u. So it's negative integral of e to the u du. What's the integral of e to the u? E to the u. So this gives me negative e to the u plus c. Plug in our u. So negative e to the negative x plus c. I think that this question actually had the most people get it right on the test. Alright, number 15. Okay, number 15 was not especially difficult. One thing that would have helped is if you knew what the ln of 1 is. But x divided by x squared plus 1 dx. Here's another one where you just got to practice knowing about u, okay? I can't separate these. If it was flipped, if it was the integral of x squared plus 1 divided by x, you can actually separate this one. If you guys remember this one, you can kind of separate to x squared over x plus 1 over x. But this one I can't separate. When it's in the denominator, you can't separate. So I just know I don't really have any options for integrating it other than u substitution, so I'm going to try that. What's the more complicated thing, x or x squared plus 1? Which makes du equal to 2x dx. I'm missing the 2, so I'm going to put a half outside. That gives me 1/2 integral. Now I'm going to change my endpoints. So 0 squared plus 1 is 1. 1 squared plus 1 is 2. The 2x dx becomes du divided by u. You could move the du outside and make it like, 1 over u du. That might help some people. What's the integral of 1 over u? It's like to the negative first power, so it's like u to the 0 over 0. You can't do that. You have to just remember integral of 1 over u. I heard a lot of people say ln. 1/2 times the ln of u from 1 to 2. Okay, and this becomes 1/2 times the ln of 2 minus the ln of 1, which becomes 1/2 times the ln of 2. What's the ln of 1? 0. If you put this answer on a short answer, full credit. Okay? Did I mark it wrong?
Yeah.
My bad. Plus 1 Alright. That's, this should have been correct. That's 0, so 1/2 ln of 2. And you get ln of 2 over 2. Now, I took this question from an AP multiple choice, and so 16, the acceleration of a particle moving along a straight line is given by a equals 6t, and it says if when the velocity at 0 is equal to 1, and its distance at 0 is equal to 3, it says, what is the position at any time t? When you see this, like at any time t, it means you're not plugging in an answer, you're just getting the formula. So I started off at 6t and it's an acceleration. Okay, can I get to position immediately or I have to go somewhere else? What do I do? I take the integral of both sides and it gets me to what? Integral of acceleration gives me velocity. So integral of a is v equals integral of 6t is 6t squared over 2 is
3t squared.
3t squared, but it's plus
C.
I need to solve for that c. How am I going to do it? So I plug in, for v I plug in 1 equals 3 times 0 squared plus c. So that now gives me a formula that's v equals 3t squared plus 1. But that's not my answer yet because it didn't want velocity, it wanted position. So now I do the integral a second time. Integral of b is now position. You can call it x. This problem called it s. Every now and then they call it s. Okay, it's up to you guys. Since the problem called it s, I'm going to call it s. But if you want to call it x, you can call it s. S equals 3t cubed over 3. That's t cubed plus t and plus c. Are these the same c's? If you want to call it c2, you can. I don't care. Alright. And then you plug in for s, you plug in 3. For t, you plug in 0. 0 cubed plus 0 plus c. So we get 3 equals c. So our answer is not 3 equals c. Our answer is s equals t cubed plus t plus 3.
Yeah, it was no way. Oh.
Right, because we plug that back into. Right? Okay. Next question was the integral from 0 to 1. 17 I thought was the easiest question on the whole test. Alright. It's the integral from 0 to 1 of 3x squared minus 2x plus 3. Now, if you didn't get this right because you were scared of the fractions, just put your answer or make it into a decimal. What's the integral of 3x squared? 3x cubed over 3 or
X
x
cubed.
cubed. What's the integral of 2x squared? Or 2x squared over 2, so just
X squared.
x squared plus
3x.
3x from 0 to 1. Trust me when I say this, the AP test will accept this as an answer. 1 minus 1 plus 3 minus 0 minus 0 plus 0. That's an acceptable answer. If you're scared to do 1 minus 1, and you're scared to do 0 minus 0 minus 0, they will do the math for you, but it's just yeah, why do I not need to put plus c?
Yeah, it's a definite, yeah.
It's a definite integral. Alright. Remember, if there's endpoints, you don't put plus c. If there's no endpoints, you do put plus c. Alright. Next one. 18. Integral from 0 to pi over 6 of cosine of 3 theta d theta. Everyone in this class should be able to get this question right. The majority of people in this class are very scared of trig. You don't need a B because most of you guys have your trig tables memorized. Okay, or can't figure them out.
We do? It's possible.
If you think about it. Alright, so I get this. It's not just cosine of x, which means I need to do u. In this case, though, it's not the one like Brenda asked about earlier where you have a cosine and a sine. It just has a cosine. So my u is going to be the inside part. So u equals 3 theta, du equals 3 d theta. So I need to put a 3 inside and a 1/3 outside. That gives me 1/3 times the integral. Okay, I need to change my endpoints. What's 0 times 3? 0. Okay, then pi over 6 times 3 is?
Or pi halves.
Pi over 6
Yeah.
times 3.
It's 3 pi over 6. Yeah, so I said that, pi halves.
Or 3 pi over 6, but you can simplify it to pi over 2.
Yeah.
Okay, and then this becomes du.
U.
So it's cosine of, this is our u.
Du.
Okay, what's the integral of cosine? Sine. The integral of cosine is positive sine. Okay, so we get 1/3 times the sine of u from 0 to pi over 2, and we should have this memorized by now. If you don't, it's not even like that whole table, it's just your outside circle. 0 is, what's that? 1, 0. Pi over 2 is 0, 1. Sine is the second one. So this is 1/3 times sine of pi halves is 1 minus sine of 0 is, so it's just 1/3. Technically, again, multiple choice, you gotta do this. Technically, free response.
Wait, when did we know this?
Technically, that's an acceptable answer on free response. No. The integral of cosine is
Positive sign.
positive sign.
Yeah, because you're going backwards. Yeah.
The derivative of cosine is negative.
Yes.
But the integral of cosine is. Just made me think for a second. That's screwed up 10 seconds. Alright. 19. Okay, this problem, average value. As soon as we see the word average value, okay, again, it's not average rate of change. Average rate of change is different. But average value is 1 over d minus a, integral of a to b of f of x dx. So on 19, it said, what's the average value on the interval from 1 to 3? So we're going to just make that 1 over 3 minus 1 from 1 to 3. And then it said x minus 3 squared. Okay, technically this is a u substitution. It's also not really too much of a u substitution because the u and the du is just going to be dx, but I would still do u substitution. So u is x minus 3, du is derivative of x is just 1 dx. So this becomes 1/2 integral. I plug in 1, 1 minus 3 is -2, 3 minus 3 is 0. Could you flip it and make it negative? Yeah, do you have to? No. U squared du. Okay, and this becomes 1/2 times integral of u squared is u cubed over 3 from -2 to 0. That gives me 1/2 times 0 cubed is 0 minus -2 cubed is. Okay, honestly, you could leave your answer like this, or 1 times 8 is 8 over 6. You could still leave your answer like this, or you can make it 4/3. It is good practice to simplify it, just because on the multiple choice, you'll need to. Alright, the next one was also average value. It's the one that said the average value of radical 3x plus 1. So it's 1 over 5 minus 0, integral from 0 to 5 of radical 3x plus 1 dx. And this one also needed a u substitution, but this one's u substitution is a little trickier. U is 3x plus 1, du is 3 dx. I put the 3 inside, that means I have to put a 1/3 outside. 1/3 times 1/5 is 1 over 15. Integral, change my endpoints. 0 plus 1 is 1. 15 plus 1 is 16 of the square root of u du. Remember, when you integrate the square root of u, you're really going to change this to look like u to the 1/2. That gives me 1 over 15 times 3/2 u to the, 2/3 u to the 3/2. And remember, it's 2/3 because it was divided by 3/2, which flips it. From 1 to 16. Okay, this is a weird one. that I would do it backwards. You know what this means? Like 16 cubed and then square root of it? If you do it backwards, it's really gonna help you out. What I would also do personally is, isn't this just a constant? I would personally, to make it easier on myself, bring it up. So I'm gonna just write 2 over 45 times, okay, 16 to the 3/2 minus 1 to the 3/2. What's 1 to the 3/2? Just 1. Okay, 16 to the 3/2, I have no idea what 16 cubed is, but we do know what the square root of 16 is. What's the square root of 16? And then what's 4 cubed? 64. So this is 2 over 45 times 64 minus 1. I'd leave that as my answer. But you could do 63. 63 times 2 is 126 over 45.
I don't want to put anybody else.
Alright. How many more do we have? Oh, that was it? No, the bonus. Do you guys want to do the bonus?
No,
really
no,
quick?
no.
Okay. No, we still have, and there's 21 also. There's 3 more. Alright, 21 is probably one of the easiest.
Guys, back up.
Okay, most people have given up by now, but it's very easy. Okay, integral from 2 to 2x of dt divided by radical t cubed plus 1. And it wants to know what is f prime of 1. Okay, so this is f of x. How do I get, as soon as I see f prime of 1, what do I need first? I need to know f prime of x. Okay, how do I get f prime of x here? I take the derivative, and I have to do the fundamental theorem of calculus, which says I put it both spots. What's the derivative of 2x? 2 times 1 divided by, what's 2x cubed? What's 2x cubed? 2x cubed. Oh. What's 2x cubed? 8x cubed. So this is what f prime of x is. Now what do? I plug in 1. So 2 times 1 divided by radical 8 times 1 is 8 plus 1. What's the square root of 8 plus 1?
3.
Square root of 9, which is 3, so it's 2 over. Okay, this is tricky. You gotta think about it. It's not that hard. Okay, yeah, the hard part was thinking it's, when I plug in 2x here, it's 2x all cubed, which becomes 8x cubed.